In this demo, I want to walk you through a hypothesis test of the unemployment rate by state. This is really the summary of the analysis. There's a separate video where I demonstrate how to do the calculations. This is more about a modeling of how you would describe your analysis to somebody and summarize your findings. So the analysis, we gathered unemployment rates by state for 2015 and 2016. I believe they were snapshots in September of each of those years. And we're interested in whether the 2016 unemployment rate is less than the 2015 unemployment rate. Obviously, lower unemployment is generally good for the economy, particularly given that we've had a sluggish growth. And so signs that the unemployment rate has fallen would be very, very welcome news. So our alternative hypothesis is that the 2016 unemployment rate's less than the 2015 rate. Therefore, our null is that the 2016 rate is greater than or equal to the 2015 rate, and so we would hope to reject that hypothesis. If we reject that hypothesis, then we demonstrate that the rates have fallen by an amount that is enough so that we could say that it's statistically significant. Simply means that there's enough evidence that the forces that are driving unemployment rates have shifted those rates lower this year than last year. If we fail to reject, then what we're saying is that there is not enough statistical evidence for us to conclude that the forces have actually shifted. And so it's possible that really we're just seeing the same unemployment that we have been seeing. So setting up our test, sort of the mathematics of our hypothesis. Again, we stated as that the 2016 population mean is less than the 2015 mean. Mathematically, we would want to set that up as that the 2016 mean minus the 2015 mean is less than 0. And that becomes our alternative hypothesis. And the null is just the opposite, so it would be that the 2016 mean minus the 2015 mean is greater than or equal to 0. This is a one-tailed test because we can reject in one direction. So we don't reject if it's either above or below some amount. We only reject if we can't find evidence that it's greater than or equal to. It is a left-tailed test because we reject if the value is too far to the left. Here's sort of a graphical representation of that. Think in terms of this as being the sampling distribution of population of sample means if the population, in fact, has a difference of 0. And so if the 2016 population minus the 2015 population has a difference of 0, that's where we would be centered on. And so you center it at whatever difference you're testing. And in our case, the only way we would reject the null hypothesis is that we wound up way over here with a difference that is so small that there's just no way that that sample could have come from a population with a mean difference between 2015 and 2016 that was 0 or more. And so that's what makes it a left-tailed test. So we go through the calculation steps. Again, I've walked through these in another video in a much more detail, but basically we state the research question. Are the 2016 unemployment rates lower than the 2015? We state our hypotheses. We set a significance level of 5%. We define our rules for when we would reject the null hypothesis. And if we don't reject it, then we fail to reject it. We have to solve for our degrees of freedom, calculate the standard error, and get our test statistic. So we've done all of that. First, we start by calculating the individual statistics for the two samples from 2016 and 2015. Then we calculate our values. Our t-critical value is minus 166. We get a statistic of minus 0.78. So 0.78 is not to the left of minus 166, so we would fail to reject. Obviously, our p-value, our critical p-value is 5%. That's what we set it at. We calculated the p-value associated with this t-statistic as 22%, and so effectively what that is suggesting is that there is a 22% chance that the data that we are observing, the samples that we have seen, could have come from a population where the mean difference between 2015 and 2016 is still 0 or greater than 0. So there's enough of a chance that it could have come from that population that we can't reject it, and so we would say it's still possible that the unemployment rates really haven't changed, and so we're going to fail to reject in this case. Again, since we can't reject the hypothesis that the 2016 unemployment rates are greater than or equal to 2015, then we can't conclude that unemployment rates have fallen in the last year, and that's how you would go through one of these tests.